Hello everyone. In today's class, let us take an example for developing a code using Huffman encoding procedure. So let me explain the procedure by taking an example, and the given problem is given the messages x1, x2, x3, x4, x5 and xx, and their probabilities are 0.4, 0.2, 0.2, 0.1, 0.07 and 0.03. So we are supposed to construct a binary code by using Huffman encoding procedure. So we have one more criteria given, that consider as low as possible for moving the composite bit. So first step in constructing the Huffman coding is whatever the given symbols, we have to arrange those in decreasing probabilities. In the given problem, they have already given the probabilities in decreasing order. So I have written as it is 0.4, 0.2, 0.2, 0.1, 0.07 and 0.03. Second step is we will be adding the last two probabilities. So we have to add last two probabilities and we have to place the probabilities in respective places. So here the probabilities is 0.4, 0.2, 0.2, 0.1. So when I add these two, the probability is 0.07 plus 0.03. So we will get 0.1. So when you add this, I will get as 0.1. Where should I place the 0.1? Already I am having 0.1. Either I should place this above 0.1 or below this 0.1. But they have given the condition as low as possible. So I will generate the new probabilities. That is 0.4 is unaffected. It remain as it is. 0.2 is as it is. This 0.2 is as it is. This 0.1 will be in its place because my new probabilities will be going as low as possible. So that is the reason I'll combine those two probabilities and I'll write it as 0.1. If they have given as high as possible, I will place this above the actual probability 0.1. But in this problem, they have given place this bit below as low as possible. So I'll consider the last priority. So next step is, once again, I will be adding these two probabilities and generate the new probability, new set of probability values. This is also probability. This is new set of probability values. Once again, I will get the new probabilities. So when I add 0.1 and 0.2, I will get 0.2. So I cannot place the 0.2 above these two probabilities because in my problem, they have given place as low as possible. So that is the reason I'll place here 0.4. This 0.2 will be in its place. This 0.2 also will be in its original place. The combined probability, I'll place it here, 0.2. Clear? So next I will add these. This is 0.4. This is 0.2. So now I will add these two probabilities. I'll get 0.4. So 0.4, always the probability should be in decreasing order. So I cannot place this 0.4 here because I should place it as low as possible. So this 0.4 I'll place as it is. The addition of this, I will place this 0.4 and this 0.2 is remaining. I'll bring it here. So next step, I will add these two probabilities, 0.4, 0.2, I'll get 0.6. It is having highest probability, so I'll take 0.6 here. I'll place the 0.6 here and this 0.4 I will place here. So what I have done here, I keep on decreasing the probabilities. Number of probabilities are decreasing by adding last two probabilities and placing in its appropriate places as the condition given in the problem. This is first step. Next step is you will be assigning the code values for each of the probabilities. So now let me tell you how to assign the code values. Okay, this is also probabilities. Now I will write the code. First I will write the code for these two. Initially, I will assign 0 and 1 for all the combined values. So here also I'll write 0 and 1. This will be in your LSB bit. So here also I'll write 0, 1. Here also I'll write 0, 1. Here also I will write 0, 1. So if change this, that means 0, 1. I'll write 0, 1. Just for differentiation, I'm writing 0, 1, 0 and 1. So this is the second step. For all combination, you just assign the code value 0, 1 and 0, 1. So next is we have to check this probability. So what is the probability of 0.6? 0.6 probability is 0. So how did we get 0.6? 0.6 we got by adding these two probabilities. So for these two probabilities, we will be writing 0 here. This 0 is assigned here. We will just see how I am assigning to the LSB. I am writing 0, 1 in all the places and be assigning 0, 0, 0 here because the combination of 0.4 and 0.6 is given to 0.6. It is having the value 0. So this 0 we are writing here. What is the code for 0.4? 1. So that 1 I will be writing here. Okay. Similarly, so now I am combining 0.2, 0.2 given to 0.4. So what is the code for 0.4? The code for 0.4 is 0, 0. So I will write 0, 0 here. Next, for this, for all probabilities, I have to fill it with code. So for this 2 is given here. What is the probability of 0.2? 0, 1. So for this 0.4, I'm having 1. So I will retain 1 as it is. Next, coming to the next step. 0.1, 0.1 combined and given as 0.2. So for 0.2, what is the probability? 0, 0, 1. So that 0, 0, 1 I will be writing here. 0, 0, 1 I will be writing. Clear? So for 0.2, this 0.2 is given for these values. And for this 0.2, what is the value you may have? 0, 0, 0. So next for this 0.2, I am having 0, 1. For this 0.4, I am having the value 1. Next is coming to previous values. 0, 1 I have. These two are combined. 0.07 and 0.03 is combined to given 0.1. It is having the code 0, 0, 1, 1. So I'll write that 0, 0, 1, 1. 0, 0, 1, 1. So this is the code. This for 0.1, you have 0, 0, 1, 0. Next you have 0, 0, 0. Next you have 0, 1, 1. So this will be your final code. Okay. So x1 with probability 0.4 is having the code 1. That means this is length. I will write length of this code is 1. x2 is having the probability 0.2 and the code is 0, 1. Its length is 2. Here it's having the probability. This is the final code. So it is having the length 3, 4. Length is 5. Length is 5. I hope you have understood the Huffman coding. Thank you.